Okay, so here's another one. So this is an interesting one because it looks like there's only one function there. It's a function within a function, right? So you don't have a product of two functions. So it looks like you can't do integration by parts, but you can. So we can always use the function constant 1, right? And it may seem strange to do that, but watch. I can always let this equal the integral of 1 times sine of ln of x dx. And then what I can do is I can integrate this and differentiate this. Now, again, it also seems, again, why would I choose this to be my u and this to be my dv? Or excuse me, this to be my dv and this to be my u. Okay? Well, it's easy in this respect. If I chose this to be my u, well, and this to be my dv, well, that means I'm going to integrate this. But if I knew how to integrate this, I wouldn't need to do integration by parts. So obviously, this is going to be my dv, this is going to be my u. So let's see what happens. Okay, so now, let me do my u's and stuff over here. So let u equal sine of the natural log of x, and my dv is going to equal 1 dx. And so now, watch what happens here. Now du is going to be what? It's going to be the derivative of the inside, right? It's going to be the derivative of the outside times the derivative of the inside. The derivative of the outside is cosine of the natural log of x times the derivative of the inside, which is what? The derivative of the inside is just 1 over x. So I'm going to get x down here. And then here, v is just going to equal x. Okay, so now let's put this in. So now, I'm going to put my, hold on a second, I'll be out of your way in a second. So this is going to be sine natural log of x times x. So there's my uv minus the integral of v du, and du is this. Okay, so there we go. Now, let's simplify this. So this is going, now the x's are going to cancel. This is going to be cosine of the natural log of x dx. And so now I'm going to integrate this again, right? So what's the integral of that? Well, I'm going to have to do integration by parts again. So now what I'm going to do is, for this piece, right? So now I got to substitute in for this piece here. So let's do it again. Okay, so in this case, u is going to be cosine of the natural log of x, and dv is going to equal, again, dx. Oops, yeah, dx. And now du equals what? Well, the derivative of the outside, which is going to be negative sine natural log of x, times the derivative of the inside, which is going to be 1 over x again, dx. Oops, there should be a dx up here too. I missed it. Dx. And now v equals x over here. So now, let's add this in here. So now, I'm going to carry this down, which is going to be x sine natural log of x minus, again, this is going to be uv, so uv is going to be what? X cosine of the natural log of x minus the integral of negative, so I'm going to pull that negative out and make this positive. So all I'm going to do is pull out the negative from here and make this positive. And so I'm going to write sine, so it's going to be v du, so I'm going to v du, so I'm going to get x times sine of the natural log of x over x dx. Okay, now let's simplify this. So this equals x sine natural log of x minus, now I'm going to distribute the minus here, minus x cosine the natural log of x minus, well now here the x's are going to cancel again, and I get minus sine of the natural log of x, oops, dx. Now notice something here. This is where I started, and I did all of this work, and I get back to where I started. I got the exact same thing. Now I'm back to where I started now. So it seems like I went into a complete circle and wasted my time. But I didn't. Because notice now I can solve this algebraically now. Because all I have to do is now add this integral to both sides. So let me rewrite this. So basically, after all this is done, this is what I have. So I'm going to rewrite this so you can see it better anyway. Okay, so this is what I have. So I'm going to end up with, not an S. Okay, now, so that's what I have. Okay, so that's where I'm at now. So now, watch what I'm going to do. I'm just going to add this integral to both sides. And there's absolutely no reason why I can't do that. So if I add this, what do I get? I get 2 times the integral of sine times the natural sine of the natural log of x dx equals this, x sine the natural log of x minus x cosine the natural log of x. And now all I have to do is divide everything by 2. So I get 1/2 here, 1/2 here, and this goes away. And now, guess what? I'm done. And there's my answer. So sometimes you look for things like this, and then it breaks down and you can solve it very simply. But again, this takes practice. Sometimes it's going to be things that you're just going to pop out at you, trial and error. And the more you do these, the more you're going to start to see, hey, and notice things, and you're going to be observant of when things happen that say, oh, I've seen this before, and then you know how to handle it. Okay, so let me see here. I think I might have one for you. Let's see here. Yes, here is one for you. Finally. Okay, so try this one on your own. And again, let me know if you need any help with it. So the integral of x squared sine x dx. Okay? And then next time we're going to start talking about, what about definite integrals? Okay? Doing integration by parts with definite integrals. So it's going to be the same thing, but we're not going to be dealing with constants of integration. We're actually going to calculate actual values of the integral. So I'll see you next time.